So good day everyone. I'm here to discuss about what is a resolution principle and its application. So I am Berhel Dapitan together with my groupmates Damalan Amajonreal de la Cruz Rinley and Franz Daculos. So the topics to be discussed: the resolution principle and the proportional case, handling variables and quantifiers, dealing with computational intractability. So what is resolution principle? Resolution principle was stated by Robinson in 1965. It is a method of theorem proving that a proceeds by constructing refutation proofs, proofs by contradiction. What is the use of the unification in AI or the artificial intelligence? Unification is a process of making two different logical atomic expressions identical by finding a substitution. So resolution principle is has an interference rule, a rule that generates new clauses which are logical consequences of some of the existing clauses. So the proportional case. Proportional resolution is a powerful rule of interference for propositional logic. Using proportional resolution without axiom schematic or any rules of interference, it is possible to build a theorem prover that is sound and complete for all the proportional logic. What's more, the search space using proportional resolution is much smaller than for standard proportional logic. So what is a clausal form? Clausal form is a proportional resolution works only in expressions in clausal form. Before the rule can be applied, the premises and the conclusion must be converted to this form. Fortunately, as we shall see, there is a simple procedure for making this conversion. So this is the types of clausal form. The first form is a literal. It is neither an atomic sentence or a negation of an atomic sentence, which is presented by sentence, which is presented by P, then followed by a clausal sentence. It's neither a literal or a disjunction of literals. If P are logic constants, then the following are clausal sentence. So if P is clausal, then the Q is clausal also, as we shall see in the example. So a clause is the set of literals in a clausal sentence. For example, the following sets are the clausal corresponds to the clausal sentence. So P is a clausal sentence. Then P and Q is also a clausal sentence. Then note that this is very important, that the empty set is also a clause. It is equivalent to an empty disjunction and therefore it is unsatisfiable. So if there is empty set, we need to find the respective value for that empty set. So entailment is what occurs if the proposition is true. For example, so this is a situational example. James rides a bike to school every morning, and also Jim can ride a bike. So in the first proposition, Jim rides a bike to school every morning. It is true. Then the proposition entails a few things. If Jim can ride a bike, then of course Jim goes to school every morning. So if the first sentence is true, then the second sentence must be true as well. That is, if Jim rides his bike to school every morning, then he must be able to ride a bike. We can say that the first sentence entails the second sentence. So the entailment could be true as if X, then Y. So they are equivalent.